Now, when it comes to transformations of graphs, there's lots of different transformations you need to know, and you must make sure that you understand what each one does to a graph when we perform the transformation on it. So let's go through them all one by one. The first type of transformation we see is a horizontal transformation. Now, if we take our curve here, y, which is equal to a function of x, x squared in this case, if we perform a horizontal transformation to it, it would be of this type. For example, f of x plus 4. Notice the plus 4 is in the brackets, and we've moved the graph 4 spaces to the left. Now, if we were to have a similar horizontal transformation labelled f of x minus 5, notice that has now moved 5 spaces to the right. Now, the important thing to remember with horizontal transformations is they move the opposite way to the way you might think in the function. So f of x plus 4 does in fact move back 4, and f of x minus 5 is the same as adding 5 or going to the right in that direction. So remember, it follows the opposite way to the way the function looks in a horizontal transformation. So for any function generally, y equals f of x, the transformation y equals f of x plus a is a move of minus a in the x direction. So y equals f of x plus 4, for example, is the move of 4 spaces back, as we've said. And y equals f of x minus 5 is a move of 5 spaces forward. Let's look now at vertical transformations. We have again our graph of x squared, which is our f of x function. Now, a vertical transformation is either going to move it up or down. Now, the first one we'll look at is y equals f of x minus 6. Notice on a vertical transformation, the minus 6 is outside of the function bracket, and the effect that that has on the graph is it moves down 6. If we look at y equals f of x plus 3 as another example, we see that original graph, y equals f of x, has moved up 3. So generally speaking, for any function y equals f of x, the transformation y equals f of x plus a is a movement of a in the y direction. Now this one makes more sense to us because y equals f of x plus 3 therefore is an add up, it moves up 3 spaces. And y equals f of x minus 6 is a move of 6 spaces down. So now we're going to look at reflections when we do a reflection to a graph. And there are 2 types of reflections you must know. And that is y equals f of minus x and also y equals minus f of x. So notice how those 2 look different, and they also have a different effect on the graph when we perform them on them. So let's first of all think about what they are. Well, the thing we need to remember is that y equals f of minus x is a reflection in the y-axis. And y equals minus f of x is a reflection in the x-axis. If you can remember those 2 points, you should be able to do any of these reflections very easily. Let's look at an example, though, of an f of minus x reflection. Let's say, for example, we have our straight line here. Now this is our function of x. Now if I do f of minus x, as we've said, that is a reflection in the y-axis. So that is where our new line would be, and we'd label it y equals f of minus x. Now if we look at this graph as our function of x, if we do f of minus x on this, again it's a reflection in the y-axis, so it would look like this. Y equals f of minus x being indicated in red. Now let's take a look at the transformation f of minus x for a cubic graph. Now you should know that the general form for a cubic graph looks like this. And if we had a reflection of that in the y-axis, then the red one would indicate what that would be like. So we would label that y equals f of minus x. So remember, f of minus x is always a reflection in the y-axis. Now let's look at the same, but for minus f of x. Now remember, all of these are going to be a reflection in the x-axis. So if we take our straight line example again, and that's our f of x, our minus f of x is that red line. And notice I'm labeling it down there now as minus f of x as the reflection's been done in the x-axis. Same for the quadratic. Here's our quadratic graph again, y equals f of x. And if we perform the reflection minus f of x on it, in other words, a reflection in the x-axis, here's where our minus f of x graph would be drawn. And finally, for that cubic form as well, there's our cubic graph there. And if we reflect that in the x-axis, we end up with that graph there. And we would label that y equals minus f of x. So all you need to do with these reflection questions is remember that f of minus x is a reflection in the y-axis and minus f of x is a reflection in the x-axis. The next thing we need to look at are the stretches that we perform when we do a transformation on a graph. And again, there are two forms that the stretch can take. Y equals a f of x, where a is a number, means a stretch of scale factor a in the y direction. And y equals f of ax means a stretch of scale factor 1 over a in the x direction. Now this is quite a tricky transformation, and so it's really important you remember what happens in each different case. So let's look at some examples. Let's first of all look at the stretch of the form a f of x. So if we have our graph again, it's just a general graph, f of x. If we want to plot half f of x, notice it's been stretched, but now it's half of what it was before. And the best way to look at it is through some of the coordinates. You can see, for example, that we have on our blue curve the coordinate 2, 4. Well, now on our red curve, that corresponds to the point 2, 2. So in other words, those y coordinates have been halved. And that's what we mean by a stretch of a half in the y direction. All your y coordinates are half the size they were. And y equals 2 f of x means we've stretched it by a scale factor of 2 in the y direction. So if you think what happens to those coordinates, all the y coordinates now are twice as big as they were. Now if we do the same but with the f of ax, remember this is a stretch of 1 over a in the x direction. So if we take our general curve again, f of x, if I want to do this time f of a third x, notice how it's been pulled in that x direction. And the x coordinates now are a third of what they were. If we look at f of 3x though, if you think what that is, that's a stretch of scale factor 1/3. So in other words, it looks like it's been squashed up more. That's because all the x coordinates now are 3 times as big as they were. Okay, so that's quite a lot of information to take in about all the different types of transformations. So what we'll do now is we'll sit down and look at some examples of how to transform some graphs. In this question, we're given a sketch of a graph and then asked to perform certain transformations on it. Now, if you take a look at the graph they've supplied us with, notice it's not an accurately drawn graph on graph paper, it's just a sketch. And that's all they're going to expect you to do, is to sketch the version of the graph after it's been transformed. So the first transformation we're going to do on it, it's f of x plus 2. Now notice the plus 2 is outside of the bracket, which means it's a move in the y direction of plus 2. So when we sketch our new graph, we're going to sketch it like so, and it's moved 2 spaces up. Now what they may ask you to do in the exam is to write down the new coordinate of the one they give you. And you see they've given us this minimum point here, so we're then going to have to write the corresponding minimum point there and write down the coordinate for it. So think what's happened. We've moved the whole graph up 2 in the y direction. So therefore this coordinate is no longer going to be 3, 0, it will be 3, 2. Now if we do on the same set of axes, the next transformation, which is f of x minus 3, you'll notice that the minus 3 is this time inside the bracket, which means it's a horizontal translation. And remember, it's always the opposite of what that number is. So we're not going to move it 3 back, we're actually going to move it 3 forward or to the right. So our next graph here, if we go back to the original one, f of x minus 3 as a sketch would look like this. Mark on that coordinate again and show what the coordinate is. So in this case, if I've moved it 3 spaces along, will be 6, 0. And if you're asked to draw 2 graphs or 2 sketches of the graphs on the same set of axes, make sure you write the correct notation next to each one, because we need to have the right equation by each one. So this one we plotted here was y equals f of x minus 3. And then this one here, y equals f of x plus 2. So we'll do 2 final transformations now, as there's 4 different transformations you need to know on this particular example. If you look again, we've got another curve. It's a sketch of a curve, and this time it has a maximum point there of minus 2, 3. And the first transformation we're going to do, f of minus x. Now remember, f of minus x means a reflection in the y-axis. So when it comes to resketching this, it's going to be just a reflection of that curve. Now you notice mine isn't a particularly good version there. We can always rub it out and make it that little bit smoother. Remember, you're not going to be marked on how effective your sketch is. The most important part is going to be that getting that point right to make sure you've shown you understood what happens to the coordinate. And if we look at that point there, it was minus 2, 3 over here, but now we've reflected it in the y-axis. So therefore, the coordinate is now going to be 2, 3. The x-coordinate has gone from being negative to positive. The last transformation we'll do on this original graph, y equals f of x, is the transformation f of 1/2 x. Now notice here, the half is inside the bracket, which means it's a stretch of scale factor 1 over a in the x direction. So what's going to happen there, if you imagine thinking of this curve as being made of elastic, we're going to pull those edges and it's going to stretch it like so. Now the thing about stretching it in that x direction is that x coordinate is not going to change in this particular transformation. So therefore, that coordinate will stay the same. But remember, let's clearly label which one applies to which transformation. This one here was y equals f of 1/2 x. And this one here was equal to y equals f of minus x. So remember, with these, the most important thing is getting that coordinate correct and not the quality of your sketching.